Today we're going to build on the notes that we looked at on Friday, where we looked at measuring angles. So today we're going to actually start looking at angle pairs. And as usual, we're going to start off first with the review, kind of the vocabulary and some of the things that we've already looked at. And in this first three questions, we're going to use the words interior, raise, and vertex. Interior, raise, and vertex to complete the blanks that are in 1, 2, and 3. Number 1, it says the blank of an angle is the region containing all the points between the two sides of the angle. That is going to be the interior of an angle. So everything in between the two rays that create the angle, that is considered to be the interior. When you use 3 points to name an angle, the vertex must go in the middle, and I know I stressed that quite often on Friday. Number 3, the sides of angle QRS are blank RS and blank, and RQ, and that's going to be the rays. Remember, the angles are composed of two rays to create the interior of each angle. When we look at 4, 5, 6, and 7, we want to determine whether or not the angles are acute, right, obtuse, or straight. The first one that we're looking at is angle SRV. So SRV, if it extends, so remember from algebra, we have the coordinate plane, and we have the quadrants 1, 2, 3, and 4. This angle SRV extends into the second quadrant, so it goes beyond the y-axis into the second quadrant, thereby making it an obtuse angle. If it's between the x-axis and the y-axis, anything in here is going to be an acute angle unless it is the x-axis and the y-axis. That's probably the easiest way to look at that one. Number 5, angle TRS. So here's TRS. That is clearly an acute angle. It's less than 90 degrees. Number 6, TRQ. So we're going to go from T to R to Q. This is an example where I was talking about it contains, or it's made up of the x-axis and the y-axis, so it has to be a right angle. And then angle VRQ is going to be a straight angle. This use your vocabulary. This sometimes, like I said, is a little bit unusual to throw in there, but we'll go ahead and complete this anyway. But the word that we're using in today's the vocabulary builder portion of this is conclude or conclusion, and the conclusion is just the end of an event or the last step in a reasoning process. So that applies a lot to proofs. And we actually, like I said before, are not going to cover proofs. The state removed that from the curriculum for geometry. But we may introduce a few little things that have to do with proofs to get you guys an understanding and to help you prepare for more advanced math classes. Number 8, if it rains, you can conclude that soccer practice will be canceled. So we're using the word conclude, which would be the verb form. And I can't spell. There we go. And then number 9, the last step of the proof is the conclusion, and that's the noun form of conclusion. All right, let's get on to some math here. So the key concept that we're looking at first is the types of angle pairs. And we have some definitions here in the green box. We have adjacent angles, which are two coplanar angles that share a common side and a common vertex, and no common interior points. So we could imagine that to look something like this. So if I have this vertex Q, R, S, and T, angle SQT and angle RQS are adjacent angles. They share a common side, which is this QS. They have a common vertex, which is Q, and then no common interior points. Vertical angles are two angles whose sides are opposite rays. So if we imagine something like this, RQS and TQU are vertical angles. Complementary angles, those are two angles that add up to 90 degrees, and then supplementary angles are angles whose sum adds up to 180 degrees. For the matching portion of this, we're just going to draw a line from each word in column A to the angles that it describes in column B. So we're looking for supplementary angles. So supplementary angles, again, are angles that add up to 180 degrees. So if we look at our diagram here, the first one we have is angle 1 and angle 2. That is not supplementary. Angle 2 and angle 3. That's, again, not supplementary. Angle 2 and angle 5. That's not supplementary. And then angle 3 and angle 6. So let me erase this. Angle 3 is a 90-degree angle. Angle 6 is also a 90-degree angle. So those two angles are supplementary. Number 11, adjacent angles. Adjacent angles share a common side. And in this particular case, we do have angle 1 and angle 2. They share a common side. We also have angle 2 and angle 3. They share a common side. So it could be either one of those. And again, this is one of the things that I'm not a big fan of with this particular set of notes that the state likes us for us to use, because this one could have multiple answers. So let's skip the adjacent angle for right now, and let's go on to vertical angles. Vertical angles are the angles that share that vertex, and then they have the opposite rays. So they're kind of two angles that are pointing towards one another, if you want to think of it like that. And again, this is another case where we had that angle 3 and angle 6. These two are vertical angles. So we also have those as supplementary angles. So there's, again, multiple answers that could come up out of this. But we've already eliminated 3 and 6. So then let's look at angle 2 and angle 5. And again, we see that those two angles are vertical from each other. And vertical angles are congruent as well. They have the same angle measure. So angle 2 and angle 5 are vertical. Complementary angles, they add up to 90 degrees. So we go back to our first two choices that we looked at earlier when we were looking at adjacent, and we narrowed it down to either 1 or 2. Well, when we look at choice 1 or choice 2, but when we look at angle 1 and angle 2, we see that those two do add up to 90 degrees. And then so that leaves our adjacent angles to be angle 2 and angle 3. Now, I do apologize for the confusion on the way that one is laid out, but I assure you that when we get to our assignment and as we go through more examples, they won't be as convoluted as that one was. All right, so identifying angle pairs. We're going to use the diagram to determine whether or not angle AFE and CFD are vertical angles. So let me just draw these in here. We have angle AFE, and then we have CFD. And we want to determine whether or not those two are vertical angles. The rays of angle AF are FE, so we have FE, and then the other one will be FA. The rays of CFD are FC, they give us that one, and then the other one would have to be FD. So complete each statement. FE, that would be this segment, or this ray right here, and blank are opposite rays. So the opposite ray would be the one that goes in the other direction. That would be FC. FA and blank are opposite rays. So again, it goes in the opposite direction. That would be FD. And then now we want to determine whether or not AFE and angle AF. It says AFE, and that should be CFD. Are vertical angles. And they are vertical angles because they are made up of opposite rays and they share a vertex. So yes, they are opposite angles. One day I will make it through a set of notes without doing that. Today's not that day. All right, let's see. Problem number 2, making conclusions from a diagram. Can we conclude that line TW, or segment TW, is congruent to segment WV? And if we haven't looked at it already, or if you don't recall, this symbol right here means congruent. So our segment TW and WV congruent. So TW is this segment here, and WV is this segment here. So circle the items marked as congruent in the diagram. Now these tick marks that you see on TW and WV indicate that those two are congruent. So PW and WQ are not indicated as being congruent. Angle TWQ and angle PWP, they are not indicated as being congruent, and neither is angle TWQ and VWQ. Because of these little tick marks, and because each segment only has one tick mark, that means those two are congruent to one another. So we know that TW and WV are congruent. Can we conclude this to be true? Yes, we can, because it is actually given to us. Notationally, it just shows us that they are congruent to each other. If we similarly had tick marks like this, then we could say that all 4 segments are congruent. If we had a double tick mark here and here, then we could say that TW and WV are congruent, and then we could also say that PW and WQ are congruent. So you just want to look at how those tick marks, or the congruency indicators, are given to you in any particular problem. Postulate number 19, the linear pair postulate. If 2 angles form a linear pair, then they are supplementary, which means they add up to 180 degrees. So if angle A and angle B form a linear pair, then the measure of angle A plus the measure of angle B has to be equal to 180. All right, that goes back to our definition of a supplementary angle at the beginning of this set of notes. And we'll apply that here in problem number 3. Angle KPL and JPL are a linear pair. The measure of angle KPL is 2x plus 24. The measure of JPL is 4x plus 36. Can we verify that the measure of KPL is 64 and the measure of JPL is 116? Which one of these is a way to check this to see if the solution is correct? First one says draw a diagram. If it looks good, then the solutions are correct. Diagrams are not always accurate. You have to be really careful with diagrams unless they are clearly labeled and precisely drawn. The second one says substitute the solutions in the original problem statement. That is definitely what we want to do. So when we set this up, we are given that, and there's actually a couple of different ways that we can go about doing this. The first method that we could do is we could say that angle JPL is equal to 4x plus 36, and it is given to us that JPL, or we're testing that JPL is 116 degrees. So we can take 116 and replace angle JPL. And then just now we would go through and solve this for x. So we subtract 36 from both sides, divide by 4, and we get x is equal to 20. If the statement or the claim is correct that KPL is 64 and JPL is 116, we can solve for both angle pairs, and in each case x should be 20 degrees. So let's see, we have KPL now is equal to 2x plus 24. And we're going to substitute in KPL is given as being 64 degrees. Subtract 24 from both sides, divide by 2, and we get x is equal to 20 in both cases. Another alternative way to go about checking this is to take both angle pairs. We have 2x plus 24 plus 4x plus 36 is equal to 180, because the claim is that they are a linear pair. And then we can go through and solve this. So 2x plus 4x is 6x. 24 plus 36 is 60. Then we would subtract 60 from both sides. So that gives us 6x is equal to 120. Divide both sides by 6, and we get x is equal to 20. Then we can take that value of 20 and put it back into each angle for x and verify that we get 64 and 116. And you'll find in both cases that you do get 64 for angle KPL and 116 for JPL. 24, how does your check show that you found the correct angle measurements? We found the same solution in both equations, and that was what we did in the yellow box there. So same solution for x. Or if you chose to do the other route, you could just say you solve for x, substitute it back into each angle, and verify that their angle measures were correct. So again, there are multiple ways we can go about solving some of these. Problem number 4 is asking us to use an angle bisector to find the angle measures. It tells us that ray KM bisects JKL. So if I draw an angle JKL, and then I have this ray KM that bisects it. Remember our definition of a bisector, it cuts something in half. The measure of JKL is 72 degrees. So what's the measure of JKM? Well, there's a very methodical approach listed out here on 25. You can choose to follow that if you want to, or you can just use your intuitive understanding of angle bisector. If JKL is 72 degrees and KM bisects it, that means it cuts it in half. What's each half going to be equal to? Half of 72 is 36, and you're done. This methodical approach is just kind of, I guess, to illustrate to you how that works out. But we can skip all that if you don't need it to indicate that you know the answer to this particular question. But I will walk through each one of these just to make sure we understand the justification for each step. But we already know the answer will be 36 degrees. First thing we're given is the measure of JKM is equal to MKL. And that's just the definition of a bisector, of angle bisector. The measure of JKM plus the measure of MKL is equal to the measure of JKL. That is the angle addition postulate. Twice the measure of JKM is equal to the measure of JKL. Because JKM and MKL are the same measure by the definition of the angle bisector, we can just simply double either JKM or we can double MKL. For this particular set of notes, they decided to double JKM, so that's just substitution. And for the next step, we've divided both sides by 2. And when we get to step 26, now we can complete our statement. We're given that the measure of JKL is 72 degrees. So then if we cut that in half, just like we said at the very beginning, without having to go through that entire process, we know that that has to be 36 degrees. So we complete the diagram. We have JKL, and then we have KM as the bisector, and that will cut it into 2 sections, both 36 degrees. The lesson check for the error analysis. Our friend calculated the value of x. What is her error? First thing she put was 4x plus 2x equals 180. She solved for x and got 30. Now, if that was the correct problem, then she's 100% right. However, 4x plus 2x, we can see, is 90 degrees. So the problem the issue that she had was that she set this equal to 180 degrees rather than 90. And when we look at the angle given, it is provided as being a 90-degree angle, which means it's right. So now we can go ahead and change this up. And we've already explained why the friend was incorrect, because she assumed it to be 180 degrees rather than 90. and that was the mistake that was made. So that is the end of our first set of notes for this week. If you have any questions, remember, just send me messages. I will be happy to answer them for you, and I hope everybody is having a great day.